everyone, and welcome back to Backend Radio.
Hi everyone, I am William and I am here with Olivia.
Today we are continuing our Backend series.
In the previous episode, we talked about queues.
Yes, a queue is like a waiting line for tasks.
Tasks wait in the queue until something processes them.
Exactly, and today we will talk about that something.
Today's topic is workers.
What is a worker? What does it do? And why is it important in backend systems?
I hear this sentence a lot. Send it to a worker.
Yes, it sounds simple, but it is an important idea.
So let's start simply. What is a worker?
A worker is a process that does background work. It takes tasks from a queue and processes them.
So the queue stores the tasks and the worker does the tasks.
Exactly, that is the main idea.
Can we use a real-life example?
Of course, imagine a coffee shop.
Backend radio is becoming coffee shop radio again.
Coffee explains everything in backend. In a coffee shop, customers wait in line.
The line is the queue.
Correct. Now, the barista takes the next order and prepares the coffee.
So the barista is like the worker.
Exactly. The worker is the part that actually does the job.
The queue does not make the coffee.
Right? The queue only holds the orders.
And the worker takes one order and prepares it.
Perfect.
What kind of jobs does a backend worker do?
Workers can send emails, generate reports, resize images, send notifications, process files, or create videos.
So workers usually handle slow or heavy work.
Yes, slow, heavy, repeated, or not immediately required.
Why not let the main application do that work?
Good question. The main application should usually answer user requests quickly.
For example, an API receives a request and sends a response.
Exactly. If the API does slow work inside the request, the user waits too long.
Can you give an example?
Sure, imagine a user uploads a profile photo. The app saves the original photo.
Then it may need to create a smaller version.
Yes, that smaller version is called a thumbnail.
Image processing can take time.
Exactly, so the API should not make the user wait for every image size.
The API can save the photo and put a thumbnail task into the queue.
Correct. Then a worker takes that task and creates the thumbnail in the background.
So the user gets a fast response, and the worker finishes the extra work later.
Exactly, that is a classic worker use case.
I like the separation. The API handles the request. The worker handles the background task.
Yes, that separation makes the system cleaner.
Is a worker a separate server?
It can be, but it does not have to be. A worker is usually a separate process. It can run on the same machine, another machine, or inside a Docker container.
So in development, it may run on my laptop.
Yes,
And in production, it may run as a separate container.
exactly. One container for the web app and one or more containers for workers.
How does the worker know what to do?
The worker listens to the queue. When a task appears, the worker takes it and runs the correct function.
What does the task contain?
Usually, it contains a task name and some data.
Like a user ID, email address, or file path?
Exactly. The worker uses that data to complete the job.
Can we connect this to a video generation system?
Yes, that is a perfect example.
A user clicks generate video.
The API receives a request.
But video generation is slow.
Yes, it may need audio, subtitles, images, and final rendering.
That should not happen inside one user request.
Correct. The API can create a video job and put it into the queue.
Then a worker picks up the video job.
Yes, the worker processes it step by step.
First, it may create audio.
Then subtitles.
Then the final video.
Exactly. And while this happens, the API is free to handle other requests.
So the worker protects the API from heavy work.
Yes, that is a very good way to say it.
The API is the front desk and the worker is the back office.
Exactly. The front desk should not do every job in the building.
Can we have more than one worker?
Yes, we can run many workers.
Why would we do that?
If there are many tasks in the queue, more workers can process them faster.
Like adding more baristas when the coffee line is too long.
Exactly. More workers can reduce waiting time.
Is adding more workers always good?
Not always. More workers can also create more pressure on the database or external services.
So if every worker writes to the database, too many workers may slow the database down.
Exactly. Scaling workers must be done carefully.
What happens if a worker fails while processing a task?
In many systems, the task can be retried later.
Retry means try again, right?
Yes, retry means try again after a failure.
For example, if an email service is down, the worker can try again later.
Exactly. Retries are useful for temporary problems.
But should a worker retry forever?
No, that can be dangerous. A task should have a retry limit.
For example, try 3 times, then mark it as failed.
Exactly. Then the system can save the error and alert the team.
So workers need monitoring.
Definitely. We should monitor queue size, failed tasks, retry count, and task duration.
Task duration means how long a task takes.
Exactly. If tasks take too long, the queue may grow.
And if the queue grows, users may wait longer for background results.
Correct. Monitoring helps us find problems early.
Can workers run scheduled tasks too?
Yes, workers can process scheduled tasks.
What is a scheduled task?
A scheduled task runs at a specific time or regularly.
Like every morning at 9.
Yes, for example, sending a daily email digest.
Or cleaning old temporary files every night.
Perfect example.
In Python, what tool do developers use for workers?
One popular tool is Celery.
Celery is the next episode, right?
Yes, in the next episode, we will explain Celery in detail.
So for now, I can say this. A worker is the concept. Celery is one Python tool that helps us run workers.
Exactly, very well said.
Can workers create problems?
Yes, workers are powerful, but they need careful design.
What should we be careful about?
Failures, retries, duplicate tasks, slow tasks, and monitoring.
Duplicate tasks means the same task runs more than once?
Yes, sometimes that can happen in distributed systems.
That sounds risky.
It can be risky if the task is not safe.
For example,
Sending the same notification twice may be annoying. But charging a payment twice would be a serious problem.
yes, that would be very bad.
So, important tasks should be designed safely.
Is this related to idempotency?
Yes, idempotency means the same operation can run more than once without creating a wrong result.
So if a task runs twice, the final result should still be correct.
Exactly, that is an important backend idea.
Let's keep that in mind but not go too deep today.
Agreed. Today's main goal is understanding workers.
Can we summarize the basic flow?
Sure. Step 1, the user sends a request to the API.
Step 2, the API creates a task.
Step 3, the task goes into a queue.
Step 4, a worker takes the task from the queue.
Step 5, the worker processes the task in the background.
Step 6, the worker saves the result or updates the status.
Perfect. That is the basic worker flow.
I think I understand now. A worker is a separate process that takes tasks from a queue and does background work.
That is a great definition.
Can we compare the API and the worker one more time?
Sure, the API handles direct user requests.
The worker handles background tasks.
The API should respond quickly.
The worker can spend more time on slow jobs.
The API should not be blocked by heavy work.
The worker keeps heavy work outside the request-response cycle.
Exactly. That is the key idea.
This is starting to feel like real backend architecture.
It is. Workers are used in many modern systems.
E-commerce systems, video platforms, notification systems, and AI applications.
Exactly. Almost every serious backend has some kind of background processing.
Let's review the main points before we finish.
First, a worker is a process that does background work.
Second, workers take tasks from a queue.
Third, workers help the API respond faster.
Fourth, workers are useful for emails, reports, images, videos, notifications, and external API calls.
Fifth, workers can be scaled by running more worker processes or containers.
Sixth, workers need retries, monitoring, and safe task design.
Excellent summary.
So, if a job is slow, heavy, or can happen later, send it to a worker.
Exactly. That is a practical rule for backend developers.
If this episode helped you, please like the video and subscribe to the channel.
In the next episode, we will talk about celery.
What is Celery? Why do Python and Django developers use it? And how does it connect queues and workers?
Thanks for listening to Backend Radio.
See you in the next episode.